All right, this is number 39 on page 197, and this is a challenging problem. It's going to be hard to do if you FOIL these out, x minus 1 times x minus 1 times x minus 1, and the same here. I'm going to show you two different ways you can do it, one that uses temporary substitution, and then another way that factors out the greatest common factor of x minus 1 squared from both those terms. So the first thing I'm going to do is I'm going to notice that I have x minus 1 in both of these binomials, this one to the third power and this one to the squared. So I'm going to temporarily substitute a simpler expression for x minus 1 and then look at the problem. So I'm going to let u, I just choose any variable, temporarily represent x minus 1. If I replace x minus 1 with a u, then I've got u to the third minus u to the second. So u to the third, u to the second equals 0. And then I can solve for u. And once I've got what u is, I'll substitute back the x minus 1 at the end. So this is just a method of substitution where we temporarily let an expression be represented by a single letter so it's easier to work with. And then we'll factor here. So I'm going to factor out the u squared, and I get u minus 1 equals 0. So that u squared is really u times u minus 1 equals 0. So there's going to be three roots. So u is equal to 0, u is equal to 0, or u is equal to a positive 1. Either of those will make that equation true. Now I'm going to substitute back what u is. Temporarily, u is representing x minus 1. So I'm going to say x minus 1 is 0, x minus 1 is 0, or x minus 1 is 1. So solving, I get x is 1, or x is 2. So that means that my solutions are 1 twice as a double root and positive 2. So that would be one way to do this problem. So I'm going to draw a line here and show a different method. Okay, so I'll rewrite the problem. Okay, if I look at the left side of this, I've got, oh, this isn't supposed to be x minus 1. It's supposed to be, I'm sorry, x minus 3. It's x minus 1. I've got x minus 1 in both these terms, in this and this. If I factor that as the greatest common factor, x minus 1 squared, to the outside, what would I need to multiply it by to get x minus 1 to the third power? I'd need one more power of x minus 1. And then I would multiply it by 1 to get this, x minus 1 squared. So x minus 1 squared times x minus 1 is x minus 1 to the third, just using distributive property, and x minus 1 squared times 1 is this. So then I'm going to simplify this, so I've got x minus 1 squared times x minus 1 minus 1, which is x minus 2, equals 0. And x minus 1 squared, I'll just write it out, both of them, x minus 1 times x minus 1 times this x minus 2 is 0. And here you get your 1, and your positive 2, which is the same as we got using the other method. So factoring out the common x minus 1 squared, the greatest common factor, that's what this is one way. I think I really kind of like the idea of using substitution of temporary value and then plugging it back in at the end. So either way, that's number 39.